Assalamualaikum and hi to all my panels and those who watch my video. I'm Hanis Binti Abdul Rahim, supervised by Technologies Dr. Akmazilah Binti Muhammad Fauzi. Here, I am presenting my final year project with the title Investigating the Effects of Thermal Treatment on Physicochemical Properties of Keluluth Honey Produced by Heterotrigona Itama. First, let's proceed to the abstract of this study. Heating at 60 degrees Celsius and above were detrimental to many of thermal bicomponents in honey and might influence changes in physicochemical properties. Thus, the purpose of this study was to investigate the effects of thermal treatment applied on physicochemical properties of Keluluth honey produced by Heterotrigona Itama. The findings in the study found that the pH, free acidity, moisture content and color of Keluluth honey was significantly affected by the temperatures and times during thermal treatment. However, total soluble solids and reducing sugar were not significantly affected by the thermal treatment. In addition, Pearson correlation shows that the most correlated physicochemical properties were moisture content and total soluble solids. In order to identify the quality and purity of the thermally treated Keluluth honey with the untreated, analysis using Fourier transform infrared (FTIR) spectroscopy shows the highest absorbance peak at 1021.29 per centimeter represents the presence of sugar in honey. FTIR analysis confirmed the effect of thermal treatment on physicochemical properties of Keluluth honey, where the higher temperatures and longer holding time attributes to the degradation of functional groups in Keluluth honey. By means, it reduced the quality of Keluluth honey from the untreated Keluluth honey. This study assured that the best condition for thermal treatment on Keluluth honey was analyzed to be at 50 degrees Celsius for 15 and 30 minutes holding time, which shows a less adverse effect on physicochemical properties. Next, the problem in this study is basic properties of Keluluth honey were probably compromised, as the practice always used thermal treatment for pasteurization. As mentioned before, heating at 60 degrees Celsius and above were detrimental to many of thermal bicomponents in honey and might have influenced changes in physicochemical properties. Yet, thermal treatment is always opted since it is easy to be done and the equipment is readily accessible. Therefore, this study was conducted to understand further on the impact of thermal treatment towards the physicochemical properties of Keluluth honey, which are pH, free acidity, moisture content, total soluble solids, color, and reducing sugar. Other objective of this study is to discover the best condition that minimize thermal effect on the quality, and the last objective is to assure the quality and purity of thermally treated Keluluth honey with analysis using FTIR. The scopes of this study are: first, this study was limited to the physicochemical properties, which are pH, free acidity, moisture content, total soluble solids, color, and reducing sugar of Keluluth honey. Second, thermal processing was carried out in the study on Keluluth honey. It began with an experimental study at temperatures of 50 degrees Celsius, 60 degrees Celsius, and 70 degrees Celsius for 5, 10, 15, and 30 minutes respectively. Third, Fourier transform infrared (FTIR) spectroscopy was used for characterization of functional groups within the peaks and analyzed the differences between untreated and thermally treated spectrum in order to observe honey's quality and purity. According to Codex Alimentarius Commission 1981, major constituents of honey are sugar with 80 gram per 100 gram and water with 20 gram per 100 gram. The other minor constituents in honey are acids, minerals, enzymes, aroma, and many more. Besides, Hellman and Hartel 1999 stated that there are two principles for thermal treatment. First, using elevated temperatures to increase the rate of reduction in the microbial population present in the raw food material. Second, transferring thermal energy into the food product as needed to achieve the desired elevated temperature. Next, for the methodology, materials used in this study were Keluluth honey, sodium hydroxide for determination of free acidity, DNSA and glucose for determination of reducing sugar. While the equipments used in this study were digital pH meter, analytical balance, vortex mixer, handheld refractometer, UV-vis spectrophotometer, filter paper, thermostatic water bath, and FTIR spectrophotometer. This is the flowchart of this study, where Keluluth honey used in this study was collected from Nyaleh Trigona Farm, Kampung Nyalas, Melaka. Then, the Keluluth honey was stored in a chiller at temperature of 10 degrees Celsius. Before the experiment started, colored honey was prepared by weighing 6 grams in each test tube for thermal treatment. Thermal treatment was conducted at temperature of 50, 60, 70 degrees Celsius for 5, 10, 15, and 30 minutes holding time. After thermal treatment of honey, the physicochemical properties of colored honey, which are pH, free acidity, moisture content, total soluble solids, color, and reducing sugar were determined. After that, FTIR analysis also conducted to the thermally treated colored honey to differentiate it from the untreated. All data collected in this study were analyzed and expressed as mean plus minus standard deviation of the triplicate samples by using one-way ANOVA and Pearson correlation in Minitab to compare the means where differences were considered significant at p-value below than 0.05. The study of significancy differences between each physicochemical properties and thermal treatment helps in deciding the best condition for thermal treatment on Heterotrigona itama honey. The trend for pH and free acidity shows that the temperature treatment that can maintain the properties of colored honey was 60 degrees Celsius. However, a study by Zare et al. 2019 stated that pH and free acidity does not highly affected by the thermal treatment. Among all physicochemical properties, only total soluble solids and reducing sugar of treated colored honey were not significant to the thermal treatment of colored honey. It can be justified that conversion of any temperature and time of thermal treatment clearly does not affect both total soluble solids and reducing sugar. Since total soluble solids and reducing sugar were not significant to the thermal treatment based on ANOVA analysis, these 4 properties can be neglected. Interestingly, moisture content and color were the only physicochemical properties that can be analyzed in terms of its effect on thermal treatment. From the analysis from the trend of moisture content and color, it can be assured that the best condition for thermal treatment of colored honey was 50 degrees Celsius for 15 to 30 minutes holding time. Moreover, the trend for thermal treatment at temperature of 50 degrees Celsius for 15 and 30 minutes seemed to maintain and give non-significantly changes on most of the physicochemical properties of thermally treated colored honey from the untreated honey. Maintaining the physicochemical properties of colored honey is important in order to preserve the quality of honey from deterioration. Furthermore, the physical properties of honey, such as color and moisture content, play an important role for customers' choice to buy a honey. Next, the FTIR spectrum of untreated and treated colored honey were analyzed as shown in the figure. Red line is untreated sample, maroon line is 30 minutes, green line is 15 minutes, blue line is 10 minutes, and black line is 5 minutes holding time. The band from 750 per centimeter to 1400 per centimeter in the figure shows the most sensitive absorption region of the honey's sugar or carbohydrate. The characteristic bands of major monosaccharides absorption, which are glucose and fructose, and disaccharides, which is sucrose, were present in the region between 900 to 1400 per centimeter. It can be observed that the highest peak between the region was 1021.29 per centimeter, which means that the infrared detected the highest presence of sugar in that peak. Comparing the untreated sample with the treated, all treated spectrum shows the same peak as the treated. So, there is none of the treated functional groups were absent after the thermal treatment. It can be seen at the temperature of 60 degrees Celsius for 15 minutes holding time bandwidth. All the absorbance peak was different than the other temperature at the same time. It can be seen that most of the stretching and bending of functional groups were lower after the thermal treatment at this temperature and time. It means that thermal treatment was believed to change the functional groups in honey. Even though the y-axis of spectrum were not started at 0, colored honey that was treated with the temperature of 50 degrees Celsius shows the stable absorbance bands difference within every minute of holding time. Besides, the absorbance peak in figure A shows the highest and narrower peak compared to figure B and C. It means that the higher the absorption, the higher the concentration of substance present in the region. Finally, the aim of the study is investigating the effect of thermal treatment on physicochemical properties of colored honey. The best condition of thermal treatment to Kelulut honey was discovered at temperature of 50 degrees Celsius with 15 and 30 minutes holding time. This study was able to help the commercialization of Kelulut honey in the world market with the best condition of thermal treatment that maintains honey's quality, nutritional values, as well as its freshness. That's all from me. I hope you enjoy watching my video. Thank you.